Hello, this is Systems of Linear Equations and Inequalities, solving systems of linear equations in three variables, example 4. And here we have a newspaper article, and it describes a swim meet, and we have to figure out how many people placed first, second, and third. The newspaper article says, in yesterday's swim meet, Roosevelt High dominated in the individual events with 24 individual event placers scoring a total of 56 points. It says first place gets 5 points, a second place finish gets 3, and a third place finish gets 1. Then it says having as many third place finishers as first and second place finishers combined really shows the team's depth. So I will start out by writing all of this information in my own words. Just reading it and having the numbers in different places, you can't see the relationships as easily. So putting it in my own words, I said there's 24 placers, and a placer is somebody who finishes first, second, or third. 56 total points. First gets 5 points, second gets 3 points, third gets 1 point, and then it says it had as many third as first and second, so that means first plus seconds equals the third place finishers. So now the trick is to take this information and come up with the equations. So it says 24 placers. So let's set up some variables here. I'll let X be my first place finishers, Y be my second, and Z will be my third place finishers. So it says there's 24 total placers. So that means if I take X, add it to Y, add it to Z, that equals 24. Now there's 56 total points. So if I take my first place finishers, multiply it times 5, second place finishers, multiply it times 3, and my third place finishers, multiply it by 1, that has to add up to 56. So that's 5x plus 3y plus z. That has to add up to 56. And let's see, I still need one more equation. And here it says the first plus the second equals the thirds. So that means if I add the first and the seconds and I subtract the thirds, I get 0. So that's x plus y minus z equals 0. Okay, now I have my three equations and three unknowns, and I'm ready to try to solve this system. The book has a very nice solution. It uses substitution to figure it out. You should follow that and understand what they did. I'm going to proceed the way we have been. I'm going to try to eliminate one of the variables from the first two equations, then eliminate the same variable from the second set of equations, and see if I can come up with a solution there. So working just with the first two equations, if I see these z's are very similar. There's one z in both. So if I multiply the first equation by -1, then add them up, I will eliminate that. So multiplying the first equation by -1, I end up with this equation. So this equation is equivalent to the first equation, and now I will just add these two equations together, and I get 4x plus 2y equals 32. Now looking at this equation, it's reducible by 2. So just to work with a little simpler equation, I'll work with 2x plus y equals 16. So that's going to be one of the equations that I have to work with. Now I'm going to look at the second two equations and try to eliminate the same variable. So I eliminated z. So now I'm going to try to eliminate z again, and boy, that works out nice for me because all I have to do is add up the equations. So this is 6x plus 4y equals 56. Okay, and looking at this equation, this is reducible by 2. So just to make it simpler, I would work with an equivalent equation, 3x plus 2y equals 28. And this is the second equation that I'm going to work with. So what I did was I figured out that I figured out two equations and two unknowns that I can work with, and if I solve those two, I can figure out x and y. So our problem gets easier and easier. So now it looks like if I multiply the first equation by -2, then my y's would cancel. So I'm going to multiply the first equation by -2. So that's -4x minus 2y equals -32. Okay, so this equation is equivalent to the first equation, and now I'm going to add them together, and I get -x equals -4. So that means x equals 4. Okay? So now I'll substitute x equals 4 into the first equation, getting this ready for substitution, and x equals 4. So I'll have 8 plus y equals 16, or y equals 8. That's subtracting 8 from both sides. So my first place finishers are 4, my second place finishers are 8, and it said that I had the same number of third place finishers as first and second combined. So that means z has to equal 12. And if you didn't remember that, you could just go to your original set of equations and substitute x equals 4 and y equals 8 into any of them, and you'll get z equals 12.